Today we talk about the key fact. Key fact is about statics term, but in instrumentation measurement and calibration, we often see that. For example, in gas detector, humidity meter, turbine vortex flow meter. Key fact describes the uncertainty of measurement. What's mean uncertainty of measurement? It's doubt of the exactly about the result of any measurement. We know every measurement is subject to the some uncertainty. If a measurement result is only complete, just how is the certification of the uncertainty in the measurement. Measurement uncertainty can come from the measure instrument, from the item being measured, from the environment, from the operator, or other source. Uncertainty measurement can use static analysis to do that. We often use two numbers to express uncertainty measurement. One is called interval, one is called confidence level. For example, 20 centimeter plus minus 1 centimeter at a level of confidence of 95%. What means this one? That's mean if you measure all the lengths is the 95% measurement, just following the 90 centimeter to the 21 centimeter. So that means uncertainty measurement. Okay. So if you want to know key factor and uncertainty measurement, we should know different error, accuracy, tolerance, and uncertainty. Error is the difference between measure value and the true value of the measure. Accuracy is equal error divided true value times 100%. Tolerance is the difference between up and low tolerance limits. Uncertainty is a quantification of the doubt about the measurement result. Okay, is uncertainty just a quantification of the doubt about the measurement result. In the uncertainty measurement is about statistics. In the statistics, we often use standard deviation. What means standard deviation? We repeat the measurement, we could get different result, but we want to know how widespread the reading are. The spread of value tell us something about the uncertainty of measurement. So standard deviation is the way to qualify the spread. It's the rule of thumb. We should know 2/3 of all reading will fall between plus and minus 1 standard deviation of the average. 95% reading will fall into 2 standard deviation. This rule is universal, so you can use this rule in everywhere. Okay, 95%. So how to go to standard deviation? How to estimate standard deviation? We can use calculation to express. For example, we have 10 number. If you want to go to standard deviation, we should first find the average value. Then here's number average value 17. Then find the difference between each reading and the average. Here is 16 minus 17 is minus 1. 19 minus 17 is positive 2. So all this number is between the 17. Then squared of each this number, minus 1, positive 2, or the minus 4 is square each one. Then find the total and divide by 9.1. We sum all these numbers, 1 plus 4 plus 1 plus 1 plus 0 plus 4 plus 9 plus 4 plus 0 plus 16. We got 40. Divide 9. Because we have 10 number, 10 minus 1 is 9. So we got 4.4. Is 4.4, we can go the standard deviation. So we use square root of 4.4, we got is the standard deviation is 2.1. This is standard deviation. This is the key fact in the instrumentation, and sometimes we call coverage factor K. So all of this is the calculation. We can use the formula in here, show you express mathematics. Okay. So where do error and uncertainty come from? Before we know, the measurement instrument come from measurement instrument. For is measurement instrument sometimes is old, sometimes is wearing, or sometimes is drafted, or sometimes reading is poor or noisy. So measurement instrument make it uncertain. Or item being measured. For example, the process line is not stable. It makes this measurement is uncertain. The measurement process is difficult to make, so that makes it uncertain. Import the uncertainty. Or operator skill. Operators, maybe everybody have different skill to do something, maybe make uncertainty measurement. Sampling issue is we should use the properly represent of the process you are trying to assess, the environment. So temperature, air pressure, humidity, or the other conditions can affect the measurement and instrumentation. Okay. Combining standard uncertainty. If you want to go the key factor, we should know statistics the term combining standard uncertainty. Is this one called combining standard uncertainty. Individual standard uncertainty calculated by summation in quadrant is called root sum of square. So the result is called combining standard uncertainty. We can use UC here, combining standard. This formula is combining standard uncertainty. Okay, so if you're combining standard uncertainty, now you can go to the coverage factor K. The combining standard uncertainty may be sort of equating one standard deviation. So the having scaled the components of uncertainty constantly to find the combining standard, we must record the result. The rescanning can be done use coverage of factor K. This coverage factor K multiply the combining standard. This coverage factor, this K factor, okay? This combining standard uncertainty just the reading. Okay, we can go to expand uncertainty. This reading, this result is called expand uncertainty. Okay, here is the coverage factor is a key factor. If different key factor have different standard deviation, is k equal 1. K equal 1 is the confidential 68% data point within one standard deviation. If k equal 2 is 90% data point, or 95% data point means that 2 standard deviation. If k equals 3, 99.7 is reading within the 3 standard deviation. Most time we use K2. K1 is not acceptable. Is K3 has a narrow window for the errors reading. Okay? What's mean? 1 standard deviation, 2 standard deviation. Sigma, 1 sigma, here is 1 standard, 1 sigma is 68%. Is 2 sigma, 2 standard deviation called 95%, 95.4%. Is 3 sigma, look here, from here to here, 3 sigma is called 3 standard deviation. So it's 99.7%. We often accept is the 2 sigma, okay, from here, 95%. Here is K2. We often use K2 is 95.4%. Okay. So practice never. If your 100 measurement make, so it's 95 measurement just following the reading, just following this area. Okay. This is called K2. K equal 2. Okay. This was the factory K. K factory. So in the practice application, first we should talk about gas detector. Gas detector, today we use methane. Personal LEL, we often use a spend methane 50%. Methane is lighter than the air, have a specific gravity 0.55. So the sensor installed often on the roof or high location. Look like this photo. It's here very high. Is the sensor in here, transmitted in here is very high sensor. Okay? But in some critical situation, the sensor knock near on the ground or close to the bottom of the equipment. In here, knock is the sensor near on the ground or but near the bottom of the equipment is transmitted in here. These two kind of installation, there are two things that have different capture gas quantity. In the no location sensor, you will use K factor. Is K equal 2 to represent the gas quantity, LEL quantity. So in the most time we use K equal 2.2. 2.2, just the transmitter manufacturer just repeat many times he got the result. K equal 2.2. So if your reading transmitter is just a span times the 2.2, the transmitter reading. Okay, but If you don't understand the statistics is k equal to, we can use simple is term, and you never use statistics. We can use a simple method to explain this one. Here is the sense install. Why you install sensing here? I think is very critical. This equipment may be leakage of LEL from bottom. If we know LEL is lighter than the air, so most LEL go to the roof. Most LEL go to the roof, but a few just in the underground. But then here he want to these things detect this LEL on the ground immediately. Then send the signal go to the transmitter activity alarm. For example, if the 10% is LEL is come out, but 8% is go to the roof. Here is the sensor just capture 2% LEL, but 2% LEL not activity alarm. Most time is 4% or 5% LEL activity alarm. So how to do this? So he use key fact 2.2, for example 2% LEL he is capture, then times the 2.2, then go to the 5% more than 4%. So that's the signal is 4.4 is 4 to 20 m is activity is the signal go to the transmitter. The transmitter activity alarm is 4.5% LEL. So that's why we use key fact to activity. See is transmitter. Okay. But if you use key factor to pump test, for example, in here we do pump test with connection. First, if your connection 25% LEL, but the transmitter just reading is more than 50% LEL. Okay, he have 2.2 key factor. But if your connection 50% LEL, the transmitter is reading is 100% LEL. So here we use key factor in the gas detector just for safety. If you as soon as possible to activity to detect this gas leakage. Okay. So we often use uncertainty, just key factor in the humidity measurement. Humidity unit we use RH, relative humidity. It's for the root of the uncertainty. He still use key factor equal to is a level of confidence of 95%. Okay. Key factor we most time we use key factor in the flow meter. This key factor is completely different to the coverage factor. Is completely different. He just the key factor defined as parcel per unit value is so then use this formula frequency got output signal frequency. So this key factor. In here we use key factor, but key factor is determined by each flow meter by the manufacturer. He used water to testing, got the key factor is ensured optimal accuracy. Just keep this key factor just make sure accuracy. Same thing is this key factor is for sure is for your accuracy. Okay. This gas detector key fact, all is for accuracy. Okay. So today we talk about the key fact in the gas detector and the humidity. Okay. Thank you very much.